In this video, we're going to be looking at a very helpful shortcut to finding the formal charge. This is something that you should be familiar with from general chemistry, but when we're looking at organic chemistry, finding the formal charge is something that you need to be able to do very quickly and accurately. When we're looking at complex structures, and solving problems, doing mechanisms, it's very important that you're able to quickly know the formal charges of the atoms involved in a molecule. So I'm sure you've seen this formula in your textbooks in general chemistry, where we see that the formal charge is equal to the number of valence electrons, let's say that valence electrons, minus the number of bonding electrons divided by 2 plus the number of lone pairs. So clearly, obviously this does work, and this is what the formal charge is telling us. But this seems to be a very complicated formula that would take a bit of time to be able to implement. So instead of doing all of this, we can do the exact same thing by looking at the formal charge as simply being the number of electrons that an atom should have minus the number of electrons that it actually does have. So should minus, has here, is all we need to worry about when we're actually trying to find the formal charge. So let's look at an example molecule here to see how this would work. So let's say that we're given an ion like the NO3 minus, for example, right? If we have NO3 minus, and we want to draw the Lewis structure, obviously. So we can say that we have our 3 oxygens here. Obviously, we know that one of these has to have a double bond in order to satisfy the octet, and this is going to have 3 lone pairs, and so is this. But this oxygen is going to have 2 lone pairs. So it's important that we know what the formal charges of the different atoms in this molecule are. So let's start off by looking at the nitrogen. Right, so if we want to find the formal charge of the nitrogen here, using should minus has. Should is basically saying the number of electrons that the periodic table says that this atom would have, the neutral atom. So a neutral nitrogen should have 5 electrons, right? So that's 5. And now what does it have? So what we're going to be doing here is simply counting each bond as a single electron. So you count each bond as a single electron and each electron in a lone pair as a single electron. So here we see that there's nothing in a lone pair, all we have are bonds. So this is 1, 2, 3, 4, and so that tells us that it has 4 while it should have 5, giving us a positive 1 formal charge, and that is actually right. The formal charge of the nitrogen is plus 1. Now, let's do the same thing for the oxygens. So let's start with this oxygen here. So we know that oxygen, according to the periodic table, should have 6 electrons. Now, what does it have? Well, we count each electron in the lone pair as a single electron, obviously. So that's 1, 2, 3, 4, 5, 6, 7, right? So we see that we have the 6 electrons here plus the 1 that we get from the bond, so that is 7, giving us a formal charge of minus 1. We have the same thing going on here, so we know that this is also minus 1. Now, what about this oxygen? The oxygen over here, again, should have 6. But what does it have? It has 1, 2, 3, 4, 5, 6. So if we're looking at a double bonding, and each line here counts as 1. So it's 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. So we have a 0 formal charge, which means we don't write anything there. And you should always remember that the formal charges of each of the individual atoms in a molecule should add up to the charge of the whole molecule. So we see that this has a minus 1 charge, and we can see that if we add up the formal charges of all our atoms, we have plus 1, minus 1, minus 1, plus 0, which is equal to minus 1, which is the formal charge, or which is the total charge of our actual molecule here. So if we want to look at another example, just to prove that it works, let's say that we're looking at let's just say a carbon bound to 3 methyls. So if we're looking at something like this, we can see that if we want to find the formal charge of the carbon here, well, all we have to do is use our should minus has. Carbon should have 4, But what we see is there's only 1, 2, 3. Sorry, it looks like I drew another bond there. There's only 3 bonds going on, so that is just 4 minus 3 or plus 1. And so there's a special name for when we see that a carbon here has a plus charge, and that is a carbocation. This is another important term that you'll come across a lot in organic chemistry. So a carbocation is simply a carbon that is a cation. A cation, remember, is an ion that has a positive charge, right? So a carbocation is simply a carbon that has a positive charge. So again, this was a very quick video to show you how we can find our formal charge very quickly, which is an important skill in organic chemistry. Hopefully you found it helpful. If you did, please check out my future videos on organic chemistry, any general chemistry videos, or if you need a review in general chemistry, you should check those out as well. And I will see you in the next video.